Welcome back to episode 5. This is probably the last episode we're going to do in this series, at least for now. If you want me to keep making more of these contents, please let me know in the comment. Let me know what you want me to make, what you want to see more of, what do you want to see less of, maybe some example attacks you want to hear about. Drop them down in the comment and let us know. But this episode is completely dedicated to Google Cloud Platform and all the different attack vectors and things that you can do within GCP. So let's roll the clip, bring on Carlos, and learn about hacking into GCP environments. Welcome back. We have another episode of Hacking the Cloud or Cloud Hacking. I'm here with Carlos again. I think it's only fair for us to also talk about Google with like GCP, Google Cloud, because I feel like they're also a big chunk of the entire like cloud service providers. And we looked at AWS so far, and I know personally from my experience that GCP and AWS are kind of similar in the root that they kind of give you the same exact services, but they're named differently. And I know exploiting Google's metadata is a lot different. It's the same IP address, but it's a lot different than AWS. So before we jump into all of that, give me a quick rundown of what makes them similar and what's different about them.
So I will say that I don't know, maybe 70% of the services are just the same one, but with different names. You're going to have S3 buckets, in Google is called storage. You are going to have virtual machines, you're going to have Kubernetes environments, you're going to have a way to launch containers, even cloud functions or lambdas. As it's called in actually it makes more sense the names that they give them in GCP than in AWS. I don't know what they are calling, like S3 or simple storage service instead of just calling it storage, or EC2 instead of virtual machines or compute, like in this case, but there are, even if the services might look the same, they might not be behaving the same way.
Okay.
Something that I like a lot. I was surprised the first time I saw it in GCP was the IAM service. So we have already talked this in the previous session about AWS, how IAM work in AWS, but in GCP is very, very, very different. So for example, in AWS you are going to have this repository, let's call it, of permissions. So each user is going to be assigned some policies, which is a JSON, which indicates what he is going to be able to do. So it's like a repository of policies. Like you have a user, you have the policy, in the policy you have what the user can do. So the thing is that in GCP you are not going to be having a central repository of policies indicating what a user can do. But in the own service, you're going to say all these principals can do this into this resource. So the policy is completely attached to the resource. And this is very fun because usually in AWS, in order to see who has access or which permission a user has access to, you can just go to the policies. In GCP, you need to go services one by one, asking which principals can access each service in order to map the permissions of a service account of a user. So it's super annoying.
Which one would you say is more complicated out of the two?
GCP, I think, because IAM in AWS looks more centralized and easy to see, but in GCP you need to go through all of the resources.
I feel like I've had more troubles with GCP, exploiting things in GCP than I have in AWS, just because I feel like everything is just more complicated. Even the dashboard looks more complicated when you log into GCP than AWS. I mean, they both look really there's a lot of stuff to look at, but I feel like GCP is crazy complicated.
Yeah, no, I completely agree. And in GCP console, you also have all these Google APIs. They can have, thousands of them. So it's super confusing because some APIs are called very similar to some GCP services. And yeah, it's kind of confusing, definitely.
So what are some of the common, mistakes or common services that are vulnerable in GCP that we can talk about?
So they are mostly the same as the one in AWS. You can find public buckets, you can find open ports in EC2 instance, you can find cloud functions vulnerable to SSRF or RC, like the demo we are going to be seeing. And when you manage to get some kind of access inside the account, inside the project, an account in GCP is called a project in GCP. It will be like the account in AWS. You will be able to find probably again over privilege principles that you could have used to previous your way in GCP.
I feel like the threat model for all these cloud service providers are the same. You get access to SSRF, you have an RCE, you want to find the IAM or whatever the name is for that particular one, and then find your way through and escalate it. So if you want, let's look at the demo. It's what it looks like.
Definitely. So in this case, we have this cloud function, which is going to be a Lambda in AWS, that if you just access it, is going to say hello world. Nothing weird there. But if we take a look to the code, we can see that it have an RC vulnerability. Actually, the RC is going to be giving you directly a reversal, because I just wanted to show how these kind of services, these cloud functions and Lambdas are usually called serverless, which doesn't mean that there is no server. It just means that you are not going to be managing the server. But I would like to show the people how a serverless execution looks like from the inside. So in this case, if we indicate an IP, a port, and a password I put in order for other people not to compromise my cloud function, we are going to be getting a reversal. We are going to take a look to the inside of the cloud function, and we are going to be playing with the metadata endpoint.
So the purpose of this is more on the, you have RCE on a Google service or a serverless function. What's next, right? Because I feel like a lot of times an RCE, a blanket RCE by itself on a serverless is usually useless. I mean, it's not useless, but the impact isn't fully there until you can show what else you can access. And just because it's serverless, it's a one-time function, it doesn't mean that it's fully gated from other services, right?
But it's also true that sometimes you can get more sensitive information from a serverless compute machine than from an EC2 instance or virtual machine. I don't know if you know this trick, but in Lambda, as you may know, whenever you try to access the function one and again, instead of using a new container for each new request, that will be very, very, very useless. You are going to be wasting a lot of resources in spinning up the function one and again. It will be running for 15 minutes, and as long as people continue using the function, the Lambda, it is not going to be shut down.
Yeah, so it reuses the same Lambda, yeah.
Exactly. So the thing is that you can abuse how the Lambda is working internally to substitute the code that is being run inside the Lambda and stealing all the requests. And if you know that this kind of requests usually are contain some kind of authentication, user authentication tokens, or privilege or sensitive information, you can actually steal that information.
So you can sniff the request, and if there's an authorization bearer, you can pull that, and then you have access to either like an employee account or another user's account. Okay, let's jump into the demo and look. So just to make it clear, we assume somebody has an RC in this case. We have a vulnerable app that has an RC, but it's what happens after you get the RC. So let's get our RC very quick.
Yeah, so here I have indicated the IP address, the port, and the password. So running this, we should get a reversal in here. So here we are.
Okay. So this is the main application that we've got, and we're in a workspace.
Yeah. So here we could see, like, for example, the code we are running.
Right.
We could see what do we have here at the beginning. In several cases, just knowing how this root folder or some content, this will allow you to fingerprint really fast the environment where you are. So for example, tools like Limpis is going to be doing automatically checks for cloud environments, and if it finds that you are in GCP, it's going to automatically dump information from metadata. Okay. So it's an easy way, because imagine that you manage to get there seeing this, just because you are compromising a URL, you don't need to know that you're in a cloud function. So this is the way to know where you are, just knowing some fingerprints.
Okay.
What else could I show you? So for example, something that happens in GCP that doesn't happen in AWS is that if you want to access the metadata endpoint, you don't need to remember that very, very complex IP address. It's not that
Just
complex.
6 numbers, yeah.
and they repeat.
Yeah.
So,
to be honest, when I first familiarized with that IP address, I keep on forgetting what it was, and one day I actually read what it was instead of just copying it. And I'm like, oh, it's just 6 numbers: 169 and 254. Repeat.
yeah, but in GCP it's even easier. You can just curl metadata.
So they have it already. Even easier. Okay.
Yeah.
So it goes compute metadata. Okay.
So
this is very similar to what we did in our previous episodes. Instead of hitting 169.254, 169.254, we're actually running a command that curls it. So we're no longer in a browser. We actually just curl for that.
exactly. So just like in AWS, if you access a folder, it's going to be indicating you what you can further access. So we take a look to this. Here we have version 1. I'm going to be copying it. We have version 1. And this is not like AWS. So AWS have 2 different versions of metadata. I have version 1 and version 2. And the thing is that in version 1 of AWS, you could access the metadata endpoint just with any kind of SSRF. Just accessing the metadata endpoint is going to be giving you all the information you are requiring. In version 2 in AWS, you are going to be needing to ask first for a token and then use that token for authentication in order to access the information. In GCP, you will always need to indicate this metadata flavor header in order to access. And this is a security mechanism that will prevent random and easy SSRF from being accessing this endpoint.
I've noticed that with a lot of the times when I'm on Google, it's not just straightforward of just saying, iframe equals to the IP or the endpoint. It's not that easy, which makes sense. You have to have this in there, however you make the request. Your export should set a header that says metadata flavor, and that's supposed to be Google, right? Okay, let's do that and see what it looks like.
That's a very good security mechanism.
Just zoom in a little bit more.
Bigger, yeah.
There we go, okay.
So if we indicate the header, go, okay, and we try again to access the same endpoint. Well, we start finding new information. Let's go to instance, for example. I miss some final slash. Well, the thing is that just like in AWS, you're going to be able to access different information.
Yeah.
Again, let's finish this first. I think is the most important part of the metadata is the credentials. So we are going to be taking a look, just like with AWS, to the credentials to access some service account in GCP. By the way, this is important. Role, as it's called in AWS, is called service account in Google.
Okay.
So it's common to find two types of credentials in GCP, but even if here you can find default and the name of the service account, we are going to see that it's actually the same credential. I don't know why they do this, but maybe this just makes the attack easier, because just knowing that using default you can access it, you don't even need to know the name.
Okay, so our demo failed, our shell died, we're gonna do it again. So now we're going back and doing like a service account, which did it earlier.
Yeah. So
and
we
now
see that.
we can do default or the security DevOps, right?
And now we take a look to the token, which is obviously the most interesting stuff. And we'll have the token. We can use this access token to impersonate the service account and access all the resources the service account has access to. If we could check like the other service account or the other folder with the name, with the actual name of the service account, which
right
is
there,
yeah, we could see that the token is actually the same one. Token. So this ends with SWV. And here, SWV.
So with AWS, what you do is you do AWS CLI config, right? And you set up your secret, your token, and your identity key, or whatever you want to call the key. How does it work with GCP? What do you do to authenticate? How do you authenticate with a token?
So in order to authenticate in GCP, you will be using gcloud auth login, and it will ask you your credentials for the browser. This will be for real users. In order to use this token, you can even use gcloud config set and some configuration name I don't remember now, or you can use a special variable name and indicate the token, and then it will be using this token for the login. I don't remember those names, but I can tell you something. They are in Hacktricks, so maybe later we can take a look to that.
Sure. Okay. So what's next?
Yeah. So we managed to get the token, and there is something extra I would like to show. If you noticed previously, in this directory list, we have these scopes thing. This is something that doesn't exist in AWS.
That's what you were saying earlier, that you have scopes for each one's a JSON file, right?
Yeah. So in AWS there is nothing like scopes, and actually I don't think even Google likes a lot scopes. The scopes basically indicates what you can use the credentials for. So imagine that you have these service accounts. We have permissions over admin permissions over virtual machines. So we can spin up virtual machines, delete them, even change the service accounts that are running. But it doesn't have any scope related to cloud platform or related to the compute engine. Even if the access account, even if the service account have those permissions, just because in the scopes assigned to this auth token, you don't have that scope, you're not going to be able to use those permissions.
Okay.
So it's kind of like a security mechanism. The problem is that if you manage to get other kind of credentials for that service account, so if instead of getting this auth token, we manage to leak some JWT credentials, sorry, not JWT credentials, some credentials from using gcloud API, you could be able to abuse those permissions. This is because the scopes is not assigned to the service account, but to the service account is running into. Okay. So even Google is going to tell you, please don't give more permissions that the service account need, even if you are only using it in this scope restricted environment.
Got it. Okay.
So that was what I wanted to show you. This is also a problem, because imagine that you managed to exploit it, you managed to get these credentials and the scopes are restricted. You actually couldn't do much. But yeah, it's another security mechanism to have into mind when you are exploiting this kind of vulnerability.
Do you usually check for the scope when you already get access to something?
Yeah,
Makes life easier, I feel like.
Yeah, because there is another API in gcloud that I find very useful. So in AWS, when you manage to leak some access, some credentials, if you cannot list IAM policies, you will just try a lot of different actions to see if you have the access. In GCP, there is actually an API who say that you can ask, hey, can this principal do this in this resource? Yeah. So that's a very good way to check for permissions. But you can check, hey, can this service account do this action in this resource? It's going to tell you, hey, it can. But if you don't have the required scope, you're not going to be able to do it. Okay,
so now that we have the token, so let's say I'm a bug bounty hunter or I want a pen test, or even for this demo, what's the next step? What do we do?
Well, obviously there are a lot of other more options to enumerate inside a metadata endpoint. In Hacktricks, you can take a look to the most interesting information you could leak from metadata. Actually, if you just copy and paste this script, it is going to be leaking it for you. As I told you, Limpis is actually doing this by default. And you asked me previously how you can use this token in order to access other APIs. Well, this is the part that you can find that information in Hacktricks. You could use this environmental variable or this configuration with gcloud that will tell gcloud to start using that token instead of the user you have configured. From that, you could use some projects. Maybe if I can access real quick to my GitHub, we can take a look to a script you can use to ask if a principal have enough permissions to do some things. So this is something that AWS doesn't have. In AWS, in order to check if you have a permission, you need to actually try to do an action related to a permission. But here with, no, this is not the repository, it's my GCP perms. It's, very indicative name. You can use this API in order to, the API is Cloud Resource Management. You could use this, yeah, that makes sense. This API just to check, well, actually what we are going to be doing here is we are going to be downloading all the GCP permissions from the GCP page, isolating them, and then we are going to indicate the user principal, which can be a user or a service account, and going through the list, saying, hey, can this service account use this permission over this service? And this will take maybe like half an hour, something like this, like there are hundreds of permissions. And then you will have an exact list of permissions that the service account you leak can use.
Got it, okay. So now that we have the token, how do we prevent? Because we looked at AWS, it was you can abuse different calls or different functionalities, and escalate your privileges. What does that look like with Google?
Yeah. So Google Privilege Escalation using IAM is actually very, very similar to AWS. At the end, you are going to have hundreds of permissions, and if you have some specific ones, you may be able to access other permissions, access other principals with other permissions. So I would like to show you a demo where we are going to be abusing a very simple privilege.
Okay.
So I have this repository which is called GCP Privilege Scripts, where you can find actually several cases for abusing different permissions, like IAM service account keys create or IAM service account get access token. Actually have the most complete list of permissions you can abuse in Hacktricks, in Cloud Hacktricks here. You can see that there are tons of permissions, but actually I don't think this is even at 10% of all the permissions you could abuse, but there are too many for one person to check them all. So in this demo, we are going to be abusing the service account set IAM policy. I wanted to abuse this permission because this, let me access here, this set IAM policy last part of the permission is something very, very common. So as I tell you at the beginning of this episode, in GCP, you don't have a repository with JSONs indicating this user can do this action over these services, but you have a service with a JSON attached that says, well, JSON or YAML or whatever, but you have the service which says who can access and what they can do over their own service. So each service is going to be having this set IAM policy. So when you are listing your own permissions, if you find you can do set IAM policy over over any resource, that means that you are going to be able to privilege. That's very, very interesting. So what we are going to be doing using this account is we will have this service account ID with no privilege but this one.
Okay.
Everything is going to be happening automatically. I'm just going to be running a command. But this service account is going to be having these permissions. With these permissions, we are going to be giving the own service account access over the attacked SA. As I told you, you give permissions over a resource. So we are going to be abusing the set IAM policy. We are going to be giving the role service account token creator and service account user.
Okay.
So this will be, let's say, the attacker. This will be the attack SAA. Then we are going to be sleeping for 80 seconds because in GCP it could take tons of seconds to apply the new policies.
Okay.
And then we are going to be just impersonating this service account in order to get an access token of the attacked service account, showing that we managed to give enough permissions to the initial service account to attack the second service account. I hope that was kind of clear.
Yeah, so it's pretty much what we're doing here is similar to the AWS thing. We did it one by one, except this time we just scripted it out to do it. Okay.
Yeah. So just to make it a little bit more clear, because I use the service account word a lot, this service account ID we have here is going to be the leaked service account. Like for example, the token we just previously leaked in the RC, and the attack service account is going to be the service account we are trying to have access to. So imagine that this service account only have these permissions, but you would like to escalate to a service account with more permissions, maybe owner or editor, and that is going to be the second service account, this one.
Got it, okay.
So now we are just going to be running the script. We're going to be running bash main. That this D is just to specify we are going to be using this scenario. I prepared this script with several scenarios. So running this, the script is already preparing the service account we are going to using to attack, the service account we are going to be attacking, so both of them. Then it's going to be doing the privilege, and once we press some enter, it is going to be even cleaning the scenario, so we don't leave things in the project. So basically what the script was doing is create both service accounts I just mentioned you and assigning the correct permissions for both of them.
Okay.
So the goal was to show how can an attacker with the specified IAM permission will be able to steal a token to impersonate a different service account.
So just to give it a quick overview, what we did is we leaked the token, we took that token, and for this step to work, you hopefully somewhere in the services, they leak the service account, the attacker finds the service account. Now using that last token that we had, we want to impersonate or escalate our privileges to the service account so we have almost equal rights.
Yeah.
Okay.
Yeah. So, well, in this case, we can see the final, in this case, we are service account creator, service account user. In this scenario, we have updated abused the permission we have to give the attacker enough permissions to impersonate the other service account. This is the step we are seeing here. So this will be the first step from this script, this one right here. We gave these two roles.
Okay.
Then we have a sleep for a couple of seconds in order to allow the
refresh
policy,
and update, yeah.
And then we abuse this other stuff in order to impersonate the attacker, in order to manage to to get a service account token for the attacked service account. This step right here. And actually the results is going to be this service account token we managed to obtain. This will be useful to impersonate the attacked service account.
So we went from one token, impersonated, leaked the other token, and this token has access to more stuff. So
yeah.
Like hypothetically in this case, I could modify different servers, different functions, maybe has access to some database, something like that.
Yeah, the goal was to show some kind of IAM Privilege Escalation technique.
Yeah.
So when just this random permission, you are going to be able to give yourself more permissions and, well, escalate in this case to impersonate other service accounts.
Is it possible to brute force for the service account name?
So custom service account names are going to be completely generated by the system administrator.
Got it.
So you can try to check common names, but it is true that in GCP a lot of different default service accounts are going to be generated. These default service accounts usually use the name of the service, for example, compute, the name of the project, that you will know the name of the project if you manage to exfiltrate the token of a service account, or the number of the project, which you will also have. So there are, like, I could tell 10 or 20 different default service accounts that are generated, but you need to know that these service accounts are generated when you use the specific service that is going to be using them. So maybe this way you could manage to leak some service account names.
Nice, very cool. I wish I knew this stuff when I was hacking Snapchat, because I have a bug years ago on Snapchat where I got a token, but we bug bounty hunters, we stopped it, but I also had no clue how to deal with it or what to do with it. But that's very cool stuff. This would be pretty much our last episode. I don't know if we're gonna do more of them. Maybe we'll do more. But for people that are watching, they want to know more about what you do. You mentioned Hacktricks already. Where else can they find you? Are you on Twitter? Are you on other platforms?
Yeah, so they can find me on Twitter. It's at Carlos Polop M. And
we'll put it right here on the screen.
Okay. And also I have even started my own Twitch channel. It's called Hacktricks_live. I used to do some stream every Wednesday just to talk about, go around some technical examples, some demos, just like this one. So I hope people will also enjoy that.
Cool. Hopefully everyone's watching this, so go follow you on Twitch, follow on Twitter, and then go to hacktricks.xyz. I get that right? See some of this stuff. Everything we talked about, all the scripts are hosted on there, and hopefully we do more of these sometimes in the future.
Definitely.
Okay, like I said, this was the last episode, at least for now. If you want to see more of these contents, you want to see more of these episodes, do me a favor, drop me a comment, let me know what you liked, let me know what you want to hear more of. I personally think that Carlos is a mountain of knowledge. He has so much to offer, so please go follow him, and also just give us ideas. What else do you want to hear about? What else do you want to learn about when it comes down to just cloud hacking? Maybe we can do some Azure, who knows? But I need you to do me a favor and drop a comment and let us know so we can bring it back for a part 2 with maybe 4 or 5 more episodes. But until then, I will see you all later. Peace.